Alright, so here we are with the Chapter 5, Section 6, Law of Cosines, to go with the last chapter of Law of Sines. So, taking a look at what we have here, our Law of Cosines is depicted by this idea. Again, your point of capital letter is across from your segment that is a lowercase letter. So those are always matching up there. And so, the equations, yes, they are kind of long, are taking, in this case, if you're talking about angle A, you end up using a squared and setting that equal to the b squared plus the c squared minus 2 times the b and c times cosine of a. So it all depends on what angle it is that you are trying to find or use, because, of course, all the sides are present. So, taking a look at what one of these triangles may look like. You can do this with a right triangle, however, you don't have to be this fancy, and you could just use regular basic trig or the Pythagorean theorem. But it could also be any acute triangle and also any obtuse triangle, so it does work on all of those. So, the next piece here is to actually try this. So right now, kind of hard to see, but this 20 degrees is actually in this angle here. So if that 20 degrees is angle C, and we have side C that we don't know, we also have a 5 length and an 11 length for the other two sides. So it looks like B is 5 and A is 11. They want you to solve, and so remember that means find all the missing pieces. So we want angle A and its measure. We also want angle B and its measure, but then also side length C. So, taking a look at how we'd set this up, at least to find side length C, we would go ahead and use our law of cosines. So, that means that we're going to use the one that uses sine of C, right, because we have angle C. And so, cosine. Cosine. So that's going to be multiplied by negative 2ab, and then it's going to be added with b squared and a squared, and then that's going to equal our c squared. So it does very much look like the Pythagorean theorem, but of course we've got this little extra chunk here. So if we fill that in, let's see, we don't know what c is, but we do know that a is 11, and b is 5. Then it's 2 times 11 times 5 times cosine of 20. So we can solve this out. We can get each of these chunks. 11 squared is 121, 5 squared is 25, and then 2 times 11, let's see, where's my calculator? 2 times 11 times 5 times cosine of 20, and don't forget to check if you are in degree mode, because it's 20 degrees. So that's 103.3662. And so if we put all of those together, c squared is going to equal, oh, I got to do it a different way, 121 plus 25 minus 103 is 42.6338, but of course we need to take the square root of both sides. So side length C is actually equal to 6.5295. So that's side length C. Okay. And now, depending on what's going on, we can actually use the law of sines, because the law of cosines is a little bit more intense than law of sines. So either way, I'm going to use, for instance, sine of C, which is 20, over the length of the C I just got, 6.5295. And then I can set that equal to, for instance, sine of B. We don't know what B is yet, but I do know that side length B is 5. So, if I'm going to solve this, I'm going to cross multiply 5 times 20, sine of 20, and then divide by the decimal we just got. So sine of 20 degrees times 5, and all of that divided by that decimal we got. So we get 0.2619 equal to sine of b, but of course we don't want sine of b, we want to take that away by doing sine inverse. And so I need to do sine inverse of the decimal I just got. And so we get a degree measure of 15.1832 for angle B. So 15.1832 degrees. And then in order to find A, we can just subtract from 180. So 180 minus the 20 degrees of C minus the 15.1832 degrees. And let's see. We're going to get 144.8168. And so those are the missing pieces that we solve for. So again, to get the first angle, to get the missing side, we ended up using the law of cosines, but then potentially once you have used the law of cosines, you are most likely able to use law of sines as well. Alright. So, taking a look at the next one, we're going to solve this one as well. Notice every side is given, and so we can't use law of sines right away because we don't have an angle across from any of these sides. So we need angle A, angle B, and angle C, the measurements of those. And in order to do that, I guess we'll go with just A first, since, hey, that's the beginning. So, let's see. A squared is going to equal B squared plus C squared minus 2BC times cosine of A. And so, A squared is 9, and B, well, that doesn't look like a B because I erased the bottom. B is 7, so 7 squared, C is 5, minus 2 times 7 times 5 times cosine of A, since we don't know it. Alright. So solving this, we have 81 and 49 and 25, and then 2 times 7 times 5 is 70, cosine of A. But we could put these two pieces together, 49 and 25, and get 74. And continuing to solve, we could subtract our 74 over. Yeah, that's not going to work. And get 7. And then continue to solve. This multiplier needs to be divided. And so 7 divided by negative 70 is negative 0.1. And then we take the cosine inverse to cancel that cosine and be left with A. So A, the angle degree, is 95.74. Alright, and now that we have an A value, we can actually use a law of sines to find this out. So sine of 95.74 over the side length of 9 can be set equal to sine of B, for instance, over 7. And so we can cross multiply 7 times sine of 95 and divide by 9. Alright, and so we get 0.7739 equal to sine of B. Take the sine inverse of both sides to cancel the sine. And we get 50.70 for angle B. which means that in order to get angle C, we subtract 95.74 and 50.70 from 180. And 95. And we get a leftover of 33.56 degrees. There they are. So, basically once you use cosine, law of cosines one time, you're pretty good after that. Just a reminder, you always want to check that the triangle exists. Especially when we were given this triangle with just side lengths, because we may have just solved a triangle that doesn't exist. Remember that the two smaller sides added together needs to be greater than the largest side. Alright. So then we get to do a few more random formulas. So if you took a look at your formula sheet, we have an area of a triangle. So if we want to find the area of this regular octagon, which is 8 equal sides and 8 equal angles, inscribed inside a circle of radius 9. So taking a look at this, if we want the area of that triangle, all we have to do is a half times BC times sine of A, or of course depending on what angle you have there. But if we call this angle A and this side A, and then of course we called the other ones B and C, in order to find the area of that, we're going to need the measure of angle A. And angle A comes from the fact that this is a regular octagon, and so there are 8 angles or 8 of these triangles within here. And so since there are 8 of those, we need 360 divided by 8. And so the measure of angle A is 45 degrees. So now we can use this idea to find the triangle area. So the triangle area is going to be a half times B, which we said was 9, times C, which we said was the other leg of 9, and then times sine of A, which we now have as 45 degrees. So the triangle area is going to be 9 times 9 times 0.5 times sine of 45 in degree mode. So the triangle area is going to be 28.6378. And of course there are 8 of them, so we're going to go ahead and multiply by 8 for that triangle area. And so times 8 is 229.10 units. We don't have a unit, but anyway, squared. Alrighty. That's kind of a lot of units squared. Good to know. Alright, so then we move on to the next formula, which is a semi-perimeter. Semi-perimeter is talking about, is needed to be noted because it's used within the formula. So, semi-perimeter is denoted by the letter S and then used in this formula for finding the area of the triangle. So it kind of just depends on if your triangle needs to find its area and has an angle. and then this one that has only sides. Alright, and so in that case, we need to find the value of s by taking all of the sides and dividing by 2. And then we need to find the area by using this thing with the square root. So to find the area of the triangle, let's call this A and B and C. So we need to find the semiperimeter, and the semiperimeter says that we take 13 plus 15 plus 18 and divide all of that by 2. And then that's 23. So we now know that S is 23. So when we want the triangle area, we take the square root of 23 times 23 minus 13 times 23 minus B, which is 15, times 23 minus 18, which is C. Alright, and so technically we're going to have 23 times 10 times 8 times 5. And so we have 9,200. And again, they didn't necessarily tell us. And so it's units squared, because they didn't necessarily give us a unit. Booyah. Alright, so that should be it for that one. And actually that, these were just reviews from before, so you don't need those. But if you wanted to practice some more proving, those would have been it. So here is our assignment that is going to use each of these. And so remember that this second formula here is because it has only sides given, and you want to find the triangle area. This one here has an angle and 2 sides, and you want to find its area, so you'd use that formula. Versus the fact that we have this law of sines now. And again, that's because you are usually not given an angle. Otherwise, if you are given an angle, you could probably do law of sines. Just kind of depends on what is given. So that is our notes. Chapter 5, Section 6.